In our lesson today, we will be looking at predicting balanced chemical equations. We'll be giving you two different reactants, and using the information that we've covered so far, you'll be identifying the reaction type, writing the chemical formulas, and then balancing the equations to show our full balanced chemical equation. So as we learn to predict the products that are being formed and write our balanced chemical equations, we need to go back to our prior knowledge of types of reactions to make sure that we remember whether it's a synthesis reaction, a decomposition reaction, a single displacement reaction, or a double displacement reaction. And so we'll use that information to now predict what's going to be formed. So let's try our first one. And again, you'll need to have your periodic table handy with you as we go through this. But in our first example, we just have potassium iodide is decomposing when heated. So the only element that we have, or compound that we have, is this potassium iodide. And we know that it is decomposing, and so we can predict that this is a decomposition reaction. So we begin to write, and we follow the rules that we've learned already. I can see that this is potassium iodide, so we know that it is ionic. When you follow your periodic table and you identify the charges for potassium and the charges for iodide, you would cross those over. I might look at the equation here and look at potassium iodide and say, well, I know that is 1 positive and iodide is 1 negative. So when I write this, I can write Ki, and when I cross it over, it's just 1 to 1. So potassium iodide decomposes. So I'm going to write my arrow, and what are the products? Well, in a decomposition reaction, that's going to break apart, and so I'm going to be left with K plus I. Now be careful here when you write the I. Iodine, is a diatomic molecule. On your periodic table, it highlights this by having it in white writing. So when I write K, that's fine, but I is diatomic, and so I need to write it as I2. The final thing that we need to do now that we've written the formula is to balance our equation. Well, if I have 2 iodines as my products, I need to make sure that I have 2 iodines as my reactants. So I add a coefficient of 2 to my reactants. I now have to consider I have 2 Ks, and so I'm going to write a 2 over here. I've now predicted and written a full balanced chemical equation. Let's look at the next example, and if you want to pause the video and try it for yourself, go ahead and do that. So we have magnesium reacts with silver nitrate. Well, magnesium I can write down. Magnesium is a metal, so it doesn't need to react with anything. It's not diatomic. It reacts with, so plus, silver nitrate. Now silver in our periodic table is Ag, and nitrate, if you remember nitrate is a polyatomic. So I need to write that, NO3. Now be careful to check the charges again. Follow our rules. Silver has a charge again of 1 positive, and nitrate also has a charge of 1 negative. So it's okay as it's written there. Those react together and they produce, well, we have to identify what type of reaction is this. The first one was decomposition. We have magnesium all by itself. So this is going to be a single displacement. It's reacting with silver nitrate. So let's go ahead and finish writing the products. In a single displacement, the metal will displace the metal. So I'll have magnesium nitrate. Now magnesium has a charge of 2 positive. So when I cross that over, I'm going to need to have 2 of those nitrate groups. And remember, following our rules from before, I'm going to write brackets around that nitrate to show that I have 2 of those. And in a single displacement, silver here gets kicked out by itself. So there is my chemical reaction. I now want to balance it. And so to balance that, we just kind of go back and forth. Here's my one kind of subscript. So I have 2 nitrates, and over here I have 1. So I'll look to balance that out by adding a coefficient. When I add that coefficient, my nitrates are balanced. I now have 2 of those nitrates, but I have 2 Ags. I have 2 silvers. So I need to come back over here, and I need to finish this off by writing a 2. It's always a good idea to double check. I have 2 AGs, I have 2 nitrates, I have 1 magnesium, and that balances what I were in my reactant side. I have 1 Mg, 2 AGs, and 2 NO3s. So it's now a full balanced chemical equation. We get 2 more examples to follow through here in our notes. And so I would encourage you to pause the video here, see how you do on your own, write it on a piece of paper, or if you're feeling comfortable in our notes, and then resume the video here when you're done. But we have here our first example. Sodium by itself is reacting when it's in contact with copper 2 iodide. Well, let's write it out, and then it might be easier to see what type of reaction we're dealing with. I have sodium, Na. Sodium is not a diatomic, so I don't need to worry about that. It's a metal by itself. And it reacts, so plus, when in contact with copper 2 iodide. So the 2, if you remember, the 2 tells us what charge of copper we're dealing with. So I have Cu, and it's charge of 2. And then we have iodide. Iodide has a charge of -1, or 1 negative. So when I crisscross those charges, I have CuI2. Well, we need to identify what type of reaction is this. I got sodium here by itself. And so if sodium is here by itself, again, we're going to have a single displacement reaction. So when I predict the products, my sodium metal is going to kick out the copper metal. So it produces, well, sodium's going to kick it out, so it's going to have NaI. Both Na and I have a charge of 1, so it's okay as it's written there. And then copper is going to be kicked out by itself. So there's my equation. We now need to make sure and we balance everything. So my NAs are good. I have 1 Na, 1 Na. I have 1 Cu, 1 Cu, but here I have 2 I's. Here I have 1. So we need to balance this. So I'm going to add a coefficient of 2 on this side. Let me change that. I'll put it in red here so it stands out. I have a coefficient of 2. And now I need to make sure I even up the NAs that I just changed. And so I'm going to add a coefficient there. So there's my balanced chemical equation. Using, again, the rules that we've talked about before for writing chemical formulas for ionic crisscrossing charges, we look at the reaction type to predict our final balanced chemical equation. Let's look at our final one. And here we have lead 2 nitrate reacting with sodium chloride. Well, you might be able to see it here, or you might need to kind of go back. But I have one kind of compound, lead 2 nitrate, reacting here with sodium chloride. So we can identify this as a double displacement. So let's go ahead and try to write this. Well, lead 2 nitrate, 2 here, is going to mean this is 2 positive, because lead can have multiple charges. The nitrate, as we looked at our earlier example, has a charge of 1 negative, or -1. We know sodium has a charge of +1, chloride has a charge of -1. So we kind of have the charges there written. That can save us some time as we write our formula. Well, lead has a symbol of Pb. So Pb and then nitrate, and we're going to have 2 of those nitrates. So it's NO3, crisscross the charges, PbNO3 2. And it reacts with sodium chloride. Sodium chloride, both those have a charge of 1, so it's just NaCl. And they react to produce. Well, in a double displacement reaction, my first goes with last, and third goes with second. So Pb is going to go with the last, PbCl. Now, when I crisscross these charges, this 2 gets crisscrossed with the chloride. So it's going to be PbCl2. So don't forget those naming rules that we looked at. And if you need to review those in our earlier videos, go back and do that. But I have PbCl2 plus NaNO3, sodium nitrate. And those both have a charge of 1, so it's okay as it's written there. Well, final thing, we need to balance everything. And so when we balance everything, I have 2 nitrates over here, and I got 1 nitrate over here. So we'll go ahead and balance that up first. So I'll put a 2 in front of there. That balances out my nitrates, but now gives me 2 NAs. Over here I only have 1 Na, so I need to balance that out. So I have 2 NAs. Double check to make sure we're good there, 2 NAs. This also gives me 2 CLs. Well, I already have 2 CLs, so we're balanced there. 1 PB and 1 PB. So we're doing what we did kind of with word equations, with writing, everything's the same, but this time in our final note here, putting it all together, we need to identify the type of reaction, and using that information, we're now predicting the products. So go ahead and try the worksheet, and if you have any other questions, make sure you contact your teacher.